Hello, let's try this question from the electric potential energy. So it states that two strands of DNA molecule are held together by hydrogen bonds between the base pairs. When an enzyme unzips the molecule to separate the two strands, it has to break these hydrogen bonds. A simplified model represents a hydrogen bond as the electrostatic interaction of 4-point charges arranged along a straight line. The figure, this figure shows the arrangement of charges for one of the hydrogen bonds between adenine and thymine. Estimate the energy that must be supplied to break this bond. So this is the diagram that is given to us. So here you have different charges Q1, Q2, Q3 and Q4 in a straight line, and the distances between these charges are given to us. Q2 and Q3 are at 0.180 nanometer. Q1 is at a distance of 0.120 nanometer. Q3 to Q4 is 0.120 nanometer. So all the charges are given to us and all the distances are given to us. The energy required to break the hydrogen bond must be great enough to overcome the electric potential energy of the hydrogen bond. And the expression of the electric potential energy is this: UE equals to K Q1 Q2 divided by R. K is the constant, Q1 Q2 are our charges, and R is the distance between those charges. So now, since we have these four charges here, so the equation for the total electric potential energy for this bond is going to be this equation. The UE equals to K Qn Qo. So with this and this, the energy between Q1 and Q3. So and divided by the distance between this point to this point. So that is going to be 0.180 nanometer plus 0.120 nanometer. So between N to O, between N to C, then between this N to C interaction. So this is done, Then between H to O, between this and this O, that is going to be this equation between H to C. So between H to C. So these are the four electric potential energies in this whole bond, which we're going to figure out. And we can take the constant K outside the equation and then plug in all the charge values, the values of all these four charges in this equation.